Ratio and proportion always comes together when we discuss relationships of numbers. But what are they really? Learn about them here in Mathematics of Engineering. Ratio is a comparison of two numbers. Say we have the two numbers denoted as P and Q. Ratio is their relationship. The ratio of one number to another number can be denoted as P over Q. And the other way to write ratio is to use a colon, where the first number P is called antecedent, and the second number Q is termed as consequent. Placing numbers into the variables, let's determine the consequent of 30 when the ratio is 5:4. If we write the ratio of 5:4, the antecedent is 5 and its consequent is 4. Same procedure with the number. Its antecedent is 30 and we are to determine the consequent. Using the colon notation is quite confusing, so it is easier to visualize the solution by using the fraction form, which can be shown as 5/4 is equal to 30 over x. By cross multiplication, we get 5x is equal to 4 times 30. To find x, divide both ends by 5 and get x as equal to 24. The next term we will define is proportion. This is the relationship of two ratios. Let's place P over Q as our first ratio and take R over S as the second ratio. We can equate them to have equal relationship, where P, Q, R, and S are called proportionals. Another way to write a proportion is through the use of colon, and the following proportion is read as P is to Q as R is to S. In this notation, P is called the first proportion and Q as the second proportion. Similarly, R is now the third proportion and S is the fourth proportion. Talking about pairings, the inner pair of Q and R is called the means, and the outer pair is called extremes. It is a rule that the product of extremes should equal the product of means. If you do the same rule when the proportion is denoted in fraction form, it uses cross multiplication just the same. There are quite a number of properties of ratio and proportion, and we itemize each here. The first one is multiplication or division by a scalar. The property of ratio shows that multiplying or dividing the numerator and denominator of a ratio by one scalar does not affect the ratio. To check this out, we can break the property down into multiplication with a, where the ratio x over y multiplied by a on both ends will still be simplified as x all over y just the same. The same thing is true when a scalar is used to divide the ratio, where the ratio still remains the same. The second property is multiplication and comparison of two ratios. In this property, note that each part of the ratio is a fraction. Say we have a all over b as a fractional antecedent, and this is compared to c over d, another fractional consequent. If they are placed in fractional form, we get a over b all upon c over d, which can be simplified into a times d over b times c. The third property discusses equal ratios. If ratios are equal, like A over B is equal to C over D, which is again equal to another ratio E over F, when the proportionals are added together, they would still give the same ratio. Let's show an example to understand this property better. Take a look that the first relationship is 8:10, and this is equivalent to 16:20. And also, these are equivalent to 40:50. We are to check if they give the same ratio when the proportionals are added together. Let's identify which variable should be collected together. A is 8, B is 10, C is 16, and D is 20. There are also E as 40 and F as 50. In fraction form, we say 8 over 10 is equal to 16 over 20 and also equal to 40 all over 50. When each fraction is reduced to its lowest terms, we get 4/5. When all numerators are added, and same with the denominators, that is 8 plus 16 plus 40 and 10 plus 20 plus 50, these can be simplified as 64 over 80, which can be reduced to 4/5 just the same. Property 4 is a relationship rule with 1. This is used commonly as guideline on the effect of a scalar with the ratio. The first case is when the ratio is greater than 1, and we are to add or subtract a positive number. If the ratio is P over Q, and we consider this as greater than 1, adding n to both the numerator and denominator will make the value less than the original ratio. Now, if n is to be subtracted from the ratio, the resulting ratio will be greater than the original ratio. Let's take a simple example to showcase what property 4 means. We use a ratio of 11 over 8. Being an improper fraction, this is greater than 1. Let's also use n as 5. If we add 5 into the ratio and compare it to the original, we can see that we transform the ratio into 16 over 13. Is 16/13 really less than 11/8? Let's take their LCD to prove this. The least common denominator for the two fractions is 104. We create equivalent fractions from the two, so 16/13 is the same as 128 over 104. 11/8 is also equivalent to 143 over 104. And indeed, 128 over 104 is less than 143 upon 104. The other case is when n is subtracted from the ratio. 11 minus 5 is 6, and 8 minus 5 is 3. So we compare 6/3 with 11 over 8. To show the comparison clearly, we again take the least common denominator, which is 24. Work on equivalent fractions, and have 48 over 24 for 6/3, and 33 over 24 for 11/8. And again, 48 over 24 is greater than 33 over 24. The other part of the fourth property is when the ratio is less than 1, where adding a scalar will make the resulting ratio greater than the original ratio, and subtracting a scalar n makes the resulting ratio less than the original. Let's use numerical examples for the discussion. Take the ratio 7/8. This is less than 1, and n is still 5. If we add 5 into the ratio, we get 12 over 13, and from the property, this should be greater than the original fraction 7/8. We take the LCD, which is 104. and convert the fractions into their equivalent. 12/13 becomes 96 over 104, and 7/8 is 91 over 104. 96 over 104 is really greater than 91 over 104. The last case is subtracting n, so the resulting ratio becomes 2/3, which we need to compare with 7/8. Again, their LCD is 24, and they can be converted into 16 over 24 for 2/3 and 21 over 24 for 7/8. 16 over 24 is truly less than 21 over 24. The fifth property is adding different numbers in the numerator and denominator. The property states that the ratio will not change with the ratio if the numbers added is the same as the original ratio. This can be explained further by using the ratio P over Q, which will be the same even when adding A and B. If the ratio of A over B is the same as P over Q. The property holds true even with inequalities. If P over Q is greater than A over B, then adding A and B into the ratio will still hold the same greater than inequality. And when P over Q is less than A over B, then adding A and B will still keep P over Q as less than P plus A over Q plus B. Property 6 discusses continuous proportion. If there are three quantities in a continuous proportion, where the proportion becomes A is to B as B is to C, by using cross multiplication, we get B squared as equal to AC. And B is then solved as the root of A times C, where A is the first proportion, B is the proportion mean, and C is the second proportion. The seventh property still holds three quantities in a continuous proportion. Only this time, the first and third proportions are equal. With A is to B as B is to C, and A is also equal to C, then by cross multiplication, AC is equal to B squared. But then C is also A, so A squared is equal to B squared. The last property contains four proportionals, thus A is to B as C is to D. There are five equivalent combinations, starting with alternando ratio, where A over C is equal to B over D. Invertendo ratio is when the quantities are jumbled into B over A as equal to D over C. Componendo ratio states A plus B over B is equal to C plus D over D. Dividendo ratio is A minus B over B is equal to C minus D over D. Then lastly, componendo and dividendo ratio combines A plus B with A minus B, which should be equal to C plus D over C minus D. What would be exponents and roots of ratios? These are called compounding ratios. Duplicate ratio of P and Q is then P squared is to Q squared. Triplicate ratio makes P is to Q as P cube is to Q cube. Then subduplicate ratio of P is to Q is P raised to 1/2 is to Q raised to 1/2. Or we can take this as the square root of P is to the square root of Q. Then the subtriplicate ratio of P is to Q is P raised to 1/3 is to Q raised to 1/3. This is just like the cube root of P is to the cube root of Q.